Hey guys, I'm making this video series for VTU M3 students, and if you're 21 scheme students, then you will be writing the exam for the first time, 21 or 31, and for 18 scheme students who have M3 backlog. And if you like these videos, please subscribe to our channel and share these videos with your classmates and friends so that it will help them also. So in this question, f of t is given as 3 square root of t plus 4 by square root of t, and we need to find f of s, which is Laplace transform f of t, which is actually the integral of the product of f of t and e power minus st with respect to t from 0 to infinity. But we don't actually have to integrate anything because we already listed basic Laplace transforms, one of which is Laplace transform of t power n is actually n plus 1 gamma of n plus 1, this is not square root, over s power n plus 1. Okay, or you more popularly known as n factorial by s power n plus 1. Okay, this is general formula. This is specific formula when n is a positive integer. If n is 1, 2, 3, 4, gamma of n plus 1 is actually n factorial. But in this case, if you rewrite this f of t, what you will get? F of t is 3 square root of t can be written as t power 1 by 2, right? Plus 4 denominator. In the denominator, square root of t can be written as t power 1 by 2, and this is actually equals to 4 t power minus 1 by 2. Whatever in the denominator, if it comes to numerator, the sign of the power changes. Okay, here it is plus 1 by 2, it will be minus 1 by 2. Okay, so in this case, to the power of t, n, we have fractions. So if we have fractions, this is the general formula. If we have 1, 2, 3, 4 positive integers, then n factorial by s power n plus 1 is the formula. Okay, so it's very simple. We already simplified the given question. So if you take Laplace transform of this, we only need one Laplace transform question here, one Laplace transform formula here. So f of s, Laplace transform f of t is f of s is equal to 3 times Laplace transform of t power 1 by 2. T power n is n plus 1 gamma over s power n plus 1. So that is 1 by 2 plus 1 gamma over s power 1 by 2 plus 1. Okay, Laplace transform of t power 1 by 2 is 1 by 2 plus 1 gamma over s plus 1. Next again plus this term. Okay, this term counted to this term. So this is 4 as it is, t power minus 1 by 2. So in place of n I have minus 1 by 2. So that is minus 1 by 2 plus 1 gamma over s power minus 1 by 2 plus 1. Okay, easy. And this can be written as 3 by 2 gamma over s power 3 by 2 plus 4 1 by 2 gamma over s power 1 by 2. Okay, so minus 1 by 2 plus 1 is 1 by 2. And what is the value of gamma 1 by 2? Okay, so you need to know 3 things about gamma functions. Okay, that's all. So first thing is gamma of 1 by 2 is square root of pi. Okay, so that's the one value, one constant you need to know. And then whenever you need to find gamma of n plus 1, it is n into gamma of n. Okay, so in this case, we need to find the gamma of 3 by 2. So that is gamma of 3 by 2 can be written as 1 by 2 plus 1. Gamma of 1 by 2 plus 1. Okay, which is, if you compare these two, n equals to 1 by 2, right? So gamma of n plus 1 can be written as n into gamma of n, right? So n is 1 by 2. So this can be written as 1 by 2 gamma of 1 by 2. So gamma of 3 by 2 can be written as 1 by 2 into gamma of 1 by 2. How? Because of this rule, this formula. Gamma of n plus 1 is n into gamma of n. And what is gamma of 1 by 2? Square root of pi. So here 1 by 2 into gamma of 1 by 2 is square root of pi. So this is how you find gamma of any value. You have to iteratively reduce this till you get gamma of 1 by 2 in the term, and then substitute that with square root of pi. Okay, so gamma of 3 by 2 is 1 by 2 into gamma of 1 by 2. Gamma of 1 by 2 is square root of pi. So 1 by 2 into square root of pi is the value of gamma of 3 by 2. So here f of s is basically 3 into 1 by 2 square root of pi, that is 3 by 2 square root of pi by s power 3 by 2 can be written as s square root of s, right? Plus 4 gamma of 1 by 2 is square root of pi by s power 1 by 2 can be written as square root of s. Okay. So power 1 by 2 and square root is very clear. I will explain how you can write power 3 by 2 as s square root of s. So s power 3 by 2 can be written as s power 1 by 2 plus 1, right? And you know a power m into a power n, if the bases are same, you can add the power. So here I have powers added, right? So I can write this as s power 1 by 2 into s power 1. Okay, using this law of exponent, I can write like this. So s power 1 is s, s power 1 by 2 is square root of s. So s power 3 by 2 is s square root of s. That's how I have written it here. Okay. Similarly, s power 5 by 2 will be s square root of s. Okay. So that I leave you to get. So this is how you solve power fraction. If you have fractions in the t power, this is how you take the Laplace transform. Okay. So you have to use the more general formula of gamma of n plus 1 by s power n plus 1. And when it comes to gamma, you need to know three things. Gamma of 1 by 2 is square root of pi. Gamma of n plus 1 is n gamma of n. And this formula is for n greater than 0. For n values less than 0, that is n value negative, if you have gamma of minus 1 by 2, okay, or gamma of minus 3 by 2, how will you do that? So that will be something like this. So gamma of minus n is n plus 1 gamma by minus n. Okay, this is the formula if you have n less than 0. Okay, so these three things you should know whenever it comes to gamma functions. Okay, so let's see one more question on this fraction powers and gamma. So the simplest way to improve your CGPA is by studying the previous year question papers, and this works for all branches, any subjects, and for engineering math subjects, especially for M3, we have prepared an e-book, solutions to previous year question papers and model papers, that I think will help you enormously. Okay, I will leave the link to the e-book in the description. Please go check out our e-book. And if you are somebody who don't want to take any chances and prepare thoroughly for the examination, and if you are somebody who needs help understanding the solutions that are written in the book, you can check out our course, which is amazing and self-paced and very affordable. And I will leave the link to the course in the description. Please go check out our course.